cost of a seismic survey versus maybe a downhole tool or a soil sample can be very different from one another. So obviously the frequency at which we take those measurements is quite important. But there's also cost from even an optimization perspective. You know, in the end, there is a capacity that the storage developer wants to fill. So it's quite important, not just from a conformance and a CO2 plume and potentially an event, right, that occurs. There's also, we want to fill this storage space as efficiently and optimally as possible, right?
Absolutely. And taking all those measurements during the lifetime of the project, you will have to take all of that information and bake it back into your model and recalibrate, right? Because you start with an assumption that you're going to be able to inject X amount of tons per year and over a number of years, the total capacity. But that could change over time. Feeding back all of that information will be key to the economics of the project.
And having a digital ecosystem in place to where you can very quickly and easily incorporate new data is quite important.
That's very true. I think injection performance and injectivity has a very large impact on the project economics. And having an accurate model and being able to conduct multiple realization of that model and update it in real time, maintain an evergreen model of the geological storage is very important, not only to predict non-performance event, but also to plan and optimize that injection. Naturally, the CO2 has tendency to migrate upward, and in a multi-well hub, then will migrate laterally as it hit less permeable zones. And then when those pressure fronts will collide, there will be deterioration of injectivity, and there will be pore space that will not be utilized properly. That will reduce the overall effective capacity of the storage hub, affecting the economics, requiring potentially drilling of infill wells or injecting in different zones that were not initially planned to be injected in. And all of that will require capital expenditure, will affect the performance and the uptime of the site, and will have tremendous impact on the project economics. So again, back to the importance of digital tools and being able to model and predict and identify non-performance events, in addition to having the right contingency plans and emergency response plans to intervene and remediate those non-performance events is very critical.
MMV, it's just something I need to have, right, to report to regulatory authorities. But I think we're raising some valuable points on the importance of MMV and MMV planning to optimize the performance of your site.
There's a regulatory requirement to make sure that the CO2 stays where it's at and that it's not causing any harm to anybody. But let's remember that the majority of the cases, these projects are being monetized by some sort of an incentive or a public funding that you will have to come up with the proof that the CO2 has been stored, the amount that you say that it's staying there and is not going anywhere or back into the atmosphere. MMV also enables the monetization of the project. And if you don't have that very well tied down, you may very well find yourself in a situation where you're not going to be able to get your credits because you can't prove that you did what you said that you did.